We have an iterated integral here. This is a double integral where we have an order of integrating first in y and then in x. Now when we integrate first in y, we do this portion of the integral thinking of y as the variable and x as a constant. So we're just going to treat x like a constant for this integral here. I'm going to keep the x integration bounds, and I'm going to perform the integral on just the y. So the integral of sine is negative cosine. So we'll have a negative x cosine of y from y equals 2 to y equals 3. And then we have the dx still. Now this can sometimes help to make sure we're keeping our variables straight, to label the x's and the y's as we go, make sure we're not messing those up at all. But all we did was integrate that sine to get a minus cosine. We treated the x like a constant. We're going to do the endpoint of integration thing from the fundamental theorem of calculus. And let's see, what do we have? When we plug in y equals 3, we have a negative x times the cosine of 3 minus a negative x times the cosine of 2 when we plug in the 2 dx. So we see what happens. We started with a function that involved both x and y. And we integrate in y, plug in the values for y, and what we end up with is something that has x's only, and we can do that dx integral. So we see we're going to end up with just a number, which makes sense because we're trying to find a volume under the surface and above the given rectangle. So it makes sense that our answer should be just a number in the end. And we see how that happens. We integrate one variable out, plug in the values for it, and we're left with just the other variable. So let's see, what do we have here? We can clean this up just a little bit. This is cosine of 2 minus cosine of 3 times x dx. And that integral, cosine 2 and cosine 3 are just constants, so those can come out of the integral. We end up with a cosine of 2 minus cosine of 3 x squared over 2 from 0 to 1. And that's just cosine of 2 minus cosine of 3 divided by 2, and that's the answer to this problem. That's the value of this double integral and the volume under that surface.